Program to calculate sum of n numbers using dynamic memory allocation function. We are going to use Malloc function. To start with, we'll try to calculate the sum of n numbers using arrays. So arrays, when we are going to use arrays, we'll be using static memory. That what I mean to say is the memories will be allocated during compile time itself. So let us try to execute the program using arrays first, using static storage allocation. Then we'll try to convert that to dynamic storage allocation by using dynamic storage allocation strategies with the help of Malloc function. So I want to have a variable to store the number of numbers to be added and index variable to vary from first number till the last number. Then an array, let us assume, of 10 to hold the values of 10 numbers if I am going to add for 10 numbers. Then sum variable which is initialized to 0 to hold the resultant sum of 10 numbers. So I have declared the variables. My first step is I need to get how many elements I'm going to find the sum, for which I'm going to find the sum. Enter number of elements. Enter number of elements. Then we need to get the input, which is of integer data type. So %d. Comma ampersand n. Then for I equal to 0, I less than n, I plus plus, I'm going to scan the value the numbers to be added. I'll be getting it in A of I. So before that I can use printf, enter the elements. And inside that for loop itself I can scan and immediately add that to the sum value. Once this is done, then printf sum %d, comma sum. I hope this code is complete now and it will work fine. Now run the code. There is some errors, I have missed semicolon. Okay. Let me add 3 numbers, 10, 20 and 30. The answer is 60. Okay, fine. Now the problem with this code when we are using static storage allocation is, if we want to add more than 10 numbers, we need to change the code. It is not scalable. Also, For that purpose, if we are going to allocate array size to hold some 100 values, many space will be wasted. So instead of using an array, we can use dynamic storage allocation strategies, and we can allocate exactly what number of memory location we want to hold the elements after getting the value of n, and store it to a pointer variable. Say for example, we can use malloc function. For that we need a pointer variable. So syntax for this one is pointer is equal to int star close bracket malloc open bracket n into size of int. What this line will do is, after getting the value of n, it is going to allocate n number of integer data type memory locations. For integer data, we need 4 bytes of memory will be allocated. So whatever may be the value of n, if it is 10, then 40 bytes of memory will be allocated, and it will be typecasted to integer pointer type, and it will be assigned to PTR. What I mean is, after allocating, say for example, n is equal to 10 means 40 bytes of memory will be allocated, and it will be assigned as a integer pointer. It will be typecasted as a integer pointer variable, and the pointer to the first memory location will be returned to this PTR value. Pointer to the first memory location will be returned to this pointer value PTR. Now while scanning, we don't use array here because we are going to use pointer. So we'll be using PTR plus I to hold the first value of the element. Now we don't use ampersand because pointers always use address. So directly we'll be taking the value in PTR plus I. So we'll be scanning the value and we'll be storing it in PTR plus I. That content has to be added to the sum. So since we want the contents in that pointer to be added to PTR, to sum, I'm using a star here. So I'll be using a star like this. So only these three changes, along with the 10th line, we are going to effectively use our memory. And after this, whenever we are using dynamic memory allocation function, then we have to explicitly call this free function to release the memory locations, allocated memory. So what are the changes we need to do? We need to declare a pointer variable, and then using malloc function we are creating space n number of memory locations to store integer values, and the pointer to the first location is returned to PTR, and we are reading the value and storing it in the pointer that is assigned in the space that is created, and PTR will be holding the address of the first pointer, and the sum has to be added to the contents inside the contents of the location shown by the pointer. So star PTR is given here. I will try to run this code. Yeah, whenever we are going to use malloc function, we have to include a library. So we need to include stdlib.h. That header file we need to include whenever we are going to use dynamic memory allocation functions. Now run the code. Enter the number of elements 3. Enter the elements 10, 20 and 30. We are getting the answer correctly. So this is how our dynamic memory allocation function, malloc function, works. So every time we use scanf statement, we have the habit of using star when we are going to use some variable, but since it is a PTR, is a pointer data type, it will be already pointing to the address, so we need not include a star ampersand while reading the input. Again, usually when we want to add some values inside a variable, we'll be giving sum plus n, sum plus I, like that. But since we are dealing with again pointer variable here, we have to explicitly specify the contents of the pointer variable. That's why star of that pointer we have given. So this code works fine. You can try and use the same code. If you're going to replace malloc function with calloc, then also it will be working. What's the difference between malloc function and calloc function? Malloc function is memory allocation function. Calloc function is contiguous allocation function. In contiguous allocation, consecutive memory location will be allocated and all the locations will be initialized with 0. That's the difference between malloc and calloc.